All right, we're going to do Unit 6, Day 2. We're going to look at multiplying and dividing radical expressions. So Day 1, we did some simplifying of expressions. We'll do some of that today. We're going to multiply or divide first and then simplify. So we're going to use those skills we learned yesterday. So learning target, I can multiply nth root radical expressions, and the second learning target, I can multiply and simplify. That's why I can divide and simplify nth root radical expressions. So first off on the front page, when multiplying nth roots, if the roots match. Okay, so for instance down here, these are both square roots, they match. These are both cube roots, so they match. If they match, we're going to combine by multiplying all the numbers under one root, and then simplify if possible, if necessary. So basically what we're doing here, if we have radical 2 times radical 8, that's the same thing as radical 2 times 8, which is the same thing as radical 16. It's not, I mean, it would be helpful in this case to go ahead and put radical 16, because that's a square root. I can square root of 16, and I get 4, and that's my answer. Okay, now notice here I'm saying assume all variables are positive, so that'll make our life easier later. There's no variables yet, but before I move the paper and forget that it's there, I want to mark that down, all variables are positive. So we're not worried about any negative roots, any absolute values, or anything like that. Now on this guy here, both square roots, this is the same thing as a square root as 3 times 6, which is 18. 18 is not a perfect square, so I wouldn't even write it down. I wouldn't even write down the square root of 18. I would just take this as a factor tree, like this is the first two factors, 3 times 6, instead of doing 18 and then 3 times 6 and keep going, I'm already there. I got 3 times 6, save myself a step. So instead of doing this, I would just leave it like this. So 3 times 2. In fact, I'll see some students do this. They'll just go over here and say 3 times 2 and not do anything else because they know it's going to combine. I just want to get all my factors out of there. So how many pairs do you have? Well, I have a pair of 3s. Because it's a square root, so I need 2. I screwed that up yesterday in the video. So I have 2 3s, pull a 3 out. The 2 is still under there, so leave it like that. So it'll be 3 radical 2. Okay, this guy here, I could do 25 times 10, which is 250. There's no cube root of 250, so I'm not going to do that. I'm just going to start factoring from right here. 5 times 5, 5 times 2. I'm looking, it's a cube root, so I need 3 to pull one out. So this would be 5 times the cube root of 2. Okay. Next guy, it's a fourth root. They're both fourth roots. They match. I could do 8 times 8 is 64. I'm not sure anything times itself 4 times equals 64 because what would it be? 2 to the 5th is 32, so 2 to the 6th would be 64, but nothing times 4. So I'm going to leave these factored. Instead of doing the fourth root of 64, I'm just going to save time and just start my factor tree right here. So 4 times 2, 4 times 2. I need 4 of something, so here's 4 of something. So I got a 2 out front, but I still have the fourth root of 2 times 2, so I got the fourth root of 4 left over. Again, you could use your calculator to take the fourth root of 8 times the fourth root of 8, get a decimal, and then compare it to what this is, the decimal. If they're the same thing, you got them right. Now, number 5, this is where yesterday we put absolute values in, just in case, if it was an odd, or if it was even. I mean, if the root was even, we had to put absolute values in. Well, here I'm going to say all variables are positive. So I don't have to worry about that. There's no negatives involved. And the only thing that messed things up was when variables were negative. So from here on out, we're not going to worry about absolute values. That was like a one-day thing. For one day, we wanted to, one day we just want to keep that in the back of your mind. On tests and quizzes, I'm going to put this on here. Assume all variables are positive. That way you don't have to worry about it. Okay. So if it didn't really make sense, you dodged a bullet. If it did make sense, that's awesome. And if you end up going on to pre-calc, that's good. It'll help you there. But we'll kind of leave things go. Now this guy here, they're both cube roots, so I could multiply everything underneath one radical. Now the numbers themselves, I'm going to treat them the same way I've been treating them. Okay, and so instead of putting them together and taking 5 times 54, getting one big number and then breaking that down, I'm going to leave them broken down. But when it comes to the variables, I'm going to combine them. So let me do the numbers first. So 54, let's see, that would be what? 9 times 6, 3 times 3, 2 times 3. So is there, out of all of these numbers, maybe I'll just throw the 5 down here, there is 3 3s. So I pull a 3 out front, and then under the cube root, there's going to be 10 left over. So I took care of the number part first. Now the variable part, if I get x squared times x to the third, that's x to the fifth. How many groups of 3 x's am I multiplying together? Well, this would be the same thing as having it's x times x times x times x times x. Well, 3 of those could come out as 1x here, but then there'd be 2 left over. So it's almost like dividing, taking 5 divided by 3 goes into it once with a remainder of 2, so there's 2 left over. Okay? And that's maybe a better way of writing it. This would be like x times x times x times x times x. So mentally you're thinking I'm doing 5. Here's a group of 3, take 1 out, but then there's 2 left over that stay under the radical. And then the y's would be y to the 7th. You could write y being multiplied by itself 7 times, or you just think, how many times is 3 going to 7? Well, it goes into it twice, so I'm going to take 2 y's out being multiplied together still, so y squared, with a remainder of 1, so there's 1 left over underneath. Okay, so that would be the answer on that. This guy here, 4th roots. Now I've got 4 times 2 is 8. Well, if I do my factor tree, 2 times 2 times 2, there's not 4 of anything. So under the root, the 4 times 2 is actually going to be stuck under there. That nothing came out for the number-wise. Now look at the variables. Like a to the third times a, that's a to the fourth. Well, it's one group of 4, so I pull 1 out. B to the third times b, that'd be b to the fourth, take 1 out. Same thing with c, take 1 out. So that is my answer. So a times b times c times the 4th root of 8. Because all variables are positive, I don't need any absolute values there. Okay, how about this guy here? Be careful, because look, the roots don't match. So that's it. That's your answer as far as I can go. I have no idea, can't simplify it, so I have no idea what to do with that. Roots match. Now I do have a 2 times 3 on the outside already, so I'm going to put 6. And then I've got a to the 5th times a, that'd be a to the 6th. That's one group. So I can pull 1a out front. B to the 3rd, that'd be b to the 6th. So I can pull 1 out. C to the 1st times c to the 5th, that'd be c to the 6th. So I can pull 1 out. Yeah, there's nothing left under the radical, so that'd be everything. This guy here, again, they don't match, so I can't multiply them together. I could see, is there something I pull out of there? So maybe I'll just check real quick. 75, well, it's 25 times 3, 5 times 5. There's not 3 of anything. Yeah, so nothing can be pulled out of that one. So I thought maybe you pull something out, you put a whole number out front, but that's it. Nothing else you can do with that guy. Okay, so be careful. Make sure you don't get tricked. They have to have the same root to be able to do it. Now, when dividing, again, the roots have to match. So if the roots match, we're going to combine by dividing all of it under one radical. Okay, so combine by dividing under one radical, and then simplify. Then simplify from there. So this, instead of, we could simplify the top, simplify the bottom so it cancels, but you could actually just do this, the square root of 243 over 27. Okay, so what's 243 divided by 27? Well, that's actually 9. So that'd equal the square root of 9, which is 3. So that one worked out kind of nice. This guy here, I'm going to have under one radical 12x to the fourth over 3x. Try to simplify everything you can here. So first off, the 12 and the 3, that'd be a 4. X to the fourth divided by x. Well, one of these would cancel one of those out, so you'd have x cubed. And now you think, I need to simplify. I did the division part, now I need to simplify. Well, the square root of 4 is 2. And then x cubed, remember when it's a square root, it's like a 2. So a pair of these x's could come out as 1x, but then you have 1x left under the radical still. Okay. This guy here, again, doing cube roots, we're looking for, when we simplify, you have to have 3 of something. But 162x to the sixth over 3x squared. Well, 162 divided by 3, that would be 54. And x to the sixth divided by x squared, well, 6 minus 2 is 4. And now do some simplifying. So 54, I'm going to do my factor tree. 9 times 6, 3 times 3 times 3 times 2. So just the numbers, I have a group of 3 threes, so I pull a 3 out front. 2 is left underneath. So 2 stuck under the radical still. Now the 4, we got 4 x's being multiplied together. Well, 3 of those can come out as 1x, but 1 of those is left under the radical. Okay. Again, we're assuming all variables positive. Don't worry about any sort of absolute values or anything like that. Okay. Now, if you really want to quiz yourself here, maybe pause the video and try these 3. Try them out, then come back and hit play and see if you did them right. Okay. So just you can do that anytime, really. You can quiz yourself to see if you know what you're doing. So now, roots match. So one big cube root, 32 divided by negative 4. 32 divided by negative 4 is negative 8. And since it's a cube root, you're allowed to have negatives. So that'd be negative 2. So that worked out kind of nice. Let's see here. So this guy, 4th root of 1024x to the 5th over 4x. So this would be the 4th root of. So 1024 divided by 4 is 256. This would be x to the 4th. Let me simplify that. Now 256 just happens to be, which we can do the factor tree. Maybe we'll do the factor tree. So 256, let's see, it would be 64 and 4. This would be 8 and 8. 2 times 4, 2 times 4. And remember I told you yesterday, they don't have to all be prime necessarily, as long as there's 3 of something. So actually I see 3 4s here. I could actually do this. Not a very good circle, but I could pull a 4 out because there's 3 4s. Now if you kept going and got 2s, you'd actually have, oh wait a second, I need to have 3 of them. Let's see, I see what I did wrong here. Let's keep going. I'm sorry, I think of cube root here. So this is actually 2 times 2, 2 times 2, 2. I need groups of 4. Here's a group of 4. Here's a group of 4. Sorry for all the messiness there. I was doing groups of 3. I should have been doing groups of 4. There's actually 2 groups of 4 2s, so I'm going to pull 2 2s out, which is actually 4. And then x to the 4th, the 4th root, take one of them out. And I'm seeing I actually wrote this down wrong too. This guy right here is a 15th power, not a 5. So that'd be 14th. So how many 4s go into 14? That's going to be a little bit harder to do. So 1 group, 2 group, 3 groups, because that'd be 12. So 3 groups of 4 go into it, and then you got left over a remainder of 2. Whew. So be careful on those. Don't make mistakes along the way. Write carefully like I did not do. Okay, last one. This guy here. So cube root of 250 divided by 2 is 125. X to the 7th over x squared is x to the 5th. And then y squared. How many groups of 3 do we have? Well, let's do 125. That's 25 times 5, and this is 5. So I got a group of 5s. Group of 3 5s, so pull a 5 out front. With x to the 5th, there's one group of 3 in there, so pull one of them out. And you'll have 2 left over, remainder of 2. Now the y squares, there's no group of 3, so they'd stay under there. So it'd be 5x times the cube root of x squared y squared.